All right, we're going to talk about how to do normal distribution using a calculator. Okay, so the first examples I'm going to do are from the textbook, page 363, example number 26. There's the link in Canvas, and you can also print out the sheet that has all the calculator instructions that I'm about to explain. So it says example 26. So let's talk about this. So it says T is the waiting time for customer service online chat. The mean waiting time is 19 and the standard deviation is 1.3, and this has to do with the online waiting time for our customers. Okay, so when you see a mean like this and standard deviation, when you're doing normal distribution, then when you do normal distribution, then they're going to write it like this, with the n like that. So you're going to see writing like this, and I just want you to be comfortable with, if you see an n, that means normal distribution. If it was a b, it would be binomial distribution. And this first thing right here is going to be the mean, and the second value here is the standard deviation. Okay, so it says 1.3 squared. Okay, so the first question says, what is the probability that the time for waiting is going to be less than 17 seconds? So the first thing I did, I just drew this to kind of help me visualize what's happening. If the mean is 19, 19 is in the center of my curve. And if we want to find out the probability of less than 17, well, 17 is to the left of 19. Duh. Okay, so now, and since it's less, we're going to start here at like the smallest negative number you can imagine and going up to 17, because there's a tiny bit of area here too. So in order to do this, you hit second var to get normal CDF, and then we do the smallest number we could possibly do, which is this here is -1 times 10 to the 99 power. So this is the smallest number the calculator knows. So -1 times 10 to the 99 power. Okay, so I can do that by hitting the negative button, and the negative button, do not make a mistake, it's not the minus sign, but it's the negative button right here. Okay, so, and then you press second and comma in order to get this E, and then 99. Okay, and then so that's where we're starting at the lowest point, and then the highest point here is 17, and then we're going to type in the mean and then the standard deviation and enter, and then that gets us our answer. Okay, so now on this sheet here, if you've got a newer calculator, it's slightly different, but it's essentially the same thing. So as I said, the lower boundary is this, the higher boundary is this, the mean and the standard deviation. Here on the newer calculator, it looks like this, same thing, lower boundary, upper boundary, the mean and standard deviation, and after you type it like that, then it comes out just like I just showed you. Okay, so anyway, so that's how you do it if it's less than. If now, this is just another example. So it says, what is the probability that it's going to be less than 21? Okay, well, 21 is to the right of 19. And so same thing, starting point is here. The ending point is at 21. The mean is still the same, and the standard deviation is still the same, and you get your answer. Now, a lot of people have been making mistakes with 3 significant figures. So this 0 does not count as a significant figure. So the 8 is the significant figure here. Converted to a decimal, this is 93.8%. Okay, now let's move this up. Okay, you might want to hit pause and copy this down. Okay, now on this one here, it says, what is the probability of getting greater than 20.3 minutes? Okay, So once again, these problems are directly from the textbook on page whatever I said it was. Okay, so what do we do? So second var, normal CDF, my starting point is 20.3, and the ending point is 10 to the power of 99. That's a very big number. So notice how this starting point was the smallest negative number up to 21. Here our starting point is 20.3, and our ending point is the largest number you can possibly imagine, 10 to the power of 99. And then just like before, we've got our mean and our standard deviation and enter. Okay, let me just type this in just so you can see what it looks like, right? Okay, so I hit enter. Okay, yeah, my battery's low. Second var, and then normal CDF, that's the second one. I go down, enter, and then I'm going to type in 20.3, comma, that's the button above the 7, and then E. So what did I say? You hit second and comma to get that capital E, and then 99, and then comma, and then 19, comma, and then 1.3, close parentheses. It still works even if you don't close the parentheses, and then I hit enter, and then I get the answer that I said we would get. Okay. Notice it says 1, 5, 8, 6, and we're going to do it in 3 significant figures. That 6 gets rounded up to a 9. Okay. Now, what part D this is an interesting question. The expected number of times with a wait time less than 21 seconds with a sample of 107 chats. Okay, so we already found this out in question B. We found the percentage of people that had a wait time of less than 21 seconds is 0.938. That's our percentage, right? So if our sample of number of chats is 107, then if we multiply this value times 107, that tells us the number of chats that are going to be less than 21 seconds. Okay, let's do our next one. Okay, this example I did not take from the Oxford book. I took it from the homework assignment, which it's in the homework assignment, which you have here. I took it from here, and I'm going to explain what we're doing here. Okay, so the time taken by students to complete a puzzle is normally distributed with a mean of 28.3 minutes and a standard deviation of 3.6. Calculate the probability that the random student takes at least 30 minutes to complete the puzzle. Okay, so I would write this as x squiggle n, because it's normal distribution. Here is our mean, the 28.3, and our standard deviation we know is 3.6. So second var to get and then 2 for normal CDF. Our starting point is at 30. Our ending point is E99, comma, our mean is 28.3. Our standard deviation is 3.6. Type that all into the calculator, and then you get 0.318. Okay. Now, part B, this is a little bit trickier. Okay, now we're going to go back to binomial distribution. Out of 10 random students, what is the probability that 5 or fewer took at least 30 minutes to complete the puzzle? Okay, so in order to do this, I have to go back to our notes from S7K. Okay, and here we learned how to do this type of problem. So in this example here in our notes, the spinner was spun 5 times. Here was our probability. what was the chance of getting at least 3? So in this example, here you have the number of times that the spin was going to happen. Here we have the probability, and here was what we wanted to find, the random variable 2. Okay, so now, same situation. 10 random students, so we're going to have a 10 here. The probability, which we just figured out in part A, and then we want to find what's the probability that 5 or fewer students took this amount of time. So we're going to put 5 here because we want to find 5 or fewer students. Okay, and then you hit enter, and then you get your probability. So you may need to watch this a couple of times, and please come to office hours if you have trouble with this. I need to start seeing people in office hours.